Hello guys, we're back looking at the Fendt 939 again. If you remember from the last video, we have two problems to solve here. One is our mismatched brake lights, don't know why they're like that, or our tail lights. And the other is our kind of dim straw hat LEDs in the cab here. We want to give them a little bit of extra power. The first thing I'm going to try and tackle is our straw hat LEDs here. So we put 120 ohm resistors on the PCB there, and it's clearly not bright enough. I thought it would be fine, but it's just clearly not enough current. So first thing I'm going to do is change to 10 ohm resistors. I'm going to put two 10 ohm resistors in here hopefully, because I think they'll fit in there without hitting anything on the top of the cab here. Then we're going to have to put in a PNP transistor here, because this PCB can't go any lower than this bar because the LEDs are going in here. So there should be enough space here to put in a SMD transistor. And then we'll need to run a ground wire from the cab down and wire it into our control board in the tractor. And after that, fingers crossed, it'll work. Probably won't really know until we get there. I'll try and do a test along the way, but realistically until we have it all wired up, it's kind of hard to know because we have everything already wired in here. It's not that easy to test it, so we'll just have to give it a go and see what happens. Well, this is as close to a test as I was able to do. I have taken I added in the two resistors for a start, so they're in on the ground side, and that's why I have them coming here going to our battery, the ground side of the battery. Then we have the positive, the VCC coming in on one side of our transistor here with surface mount transistor to try and squeeze it in there, and one of the cables which we had wired to half of the LEDs here. So if you remember in the last video or the previous video, we put 120 ohm resistor on the line for this black wire, so that's coming on to switch our transistor, so that should limit the current there so that we're safe enough. And if we test it out, we have what seems to be anyway a perfect connection. Now a little hard to tell in the brightness here, we'll have to test it in the dark tonight, but so far it looks good, and I'd say we're probably going to be alright. We've a fair bit more current now going to the LEDs than we had before, so I'd say it'll be more than adequate at this point. So next thing I'll need to do is just run a ground wire that I can bring back down into the model here, and then sort out our brake lights, and I'd say that should be us. First thing, just our tail light there. If we put on the right indicator, you can see that it's coming through perfectly bright, there's no problem there, but yet the other light is failing. So there's both indicators on, you can see that they're the same level of brightness, which is okay, but the tail lights are not coming out with the same brightness, so we need to do something about that. And I think this time it's a wiring problem, because those two LEDs are wired together, they're not being controlled by two different pins, so we need to figure out what's wrong there. Well, our brake light problem turned out to be a simple one. I had a single resistor driving the two LEDs, so I thought maybe there's a chance that the two LEDs aren't identical. It could happen that they didn't come from the same batch, and so they have different voltage drops across them. So what I did was I split the two lines, give them each a resistor, and sure enough, now when we touch the brakes or turn on our tail lights, our two LEDs are the same. So normally when I'm wiring up the model, I have usually I'd be using the same LEDs from the same batch, so you know, I'd have ordered maybe 20 LEDs, so they're all going to be the same. But when these guys are doing a big production run, they're probably getting like the cheapest LEDs, like you would, because they probably have a resistor on each LED, and that means they can use any LEDs, and it makes no difference. Like you see, we split the two, put a resistor on each LED, and perfect. So because they're buying them in like maybe, I don't know, 100,000 LEDs, they could be coming from multiple different batches, so they could all have slightly different voltage drops. So the first way I did it, the one with the lower voltage drop took most of the current, and kind of the voltage dropped, I suppose, and one LED ended up higher than the other. So that's all there was to that. I'll just put some heat shrink on the resistors here, and I think we can put it all back together. I'm pretty sure that's it sorted now. It should work. Alright, well, it's all back together now. Our tail lights are both fairly even, as you can see. Not a problem there. And we have our floodlights, our working lights. So that seems to have worked pretty well. Alright, so we'll give the lights a test in the dark here. So there's your dipped headlights, full beams, and then your work lights. So I'd say that's pretty successful. You couldn't really ask for much more than that, I don't think. It's about as good as you're going to get. Alright, well, as far as I'm concerned, that's the Fendt 939 finished. It's kind of every feature that we planned to put on it seems to be working. It's just a matter now of giving it a wee test out to see that there's no bugs or anything in the code that's just going to work perfectly. It seems to be working fine with the little tests we've done, but you want to test it for a little bit longer just to see. So probably we'll take it up and spin it around the diorama for, I don't know, 20 minutes or something, and try and pick up a few loads with the loader here or something like that, and just generally test it out properly and check that nothing goes wrong with it. So if you like that build, make sure and hit the like button, and let me know below the video if you have any comments, and I think that's it. So thanks very much for watching.